There's a liquid gold flowing through the forests of North America that most people only encounter at the breakfast table. But what if I told you that the journey from tree to bottle involves precision engineering that would rival a pharmaceutical laboratory? Deep in the heart of maple country, where winter temperatures drop below freezing and spring brings the perfect thaw, an ancient natural phenomenon meets cutting-edge industrial technology. This isn't your grandmother's backyard sugar shack. This is a multi-million-dollar operation where science, nature, and manufacturing converge to create one of the world's most beloved natural sweeteners. Behind those innocuous bottles on supermarket shelves lies a production process so intricate, so carefully orchestrated, that a single degree of temperature can mean the difference between perfection and disaster. Welcome to the hidden world of industrial maple syrup production, where tradition meets innovation in ways you never imagined. The maple syrup industry guards its secrets well. Most consumers have no idea that producing a single gallon of pure maple syrup requires approximately 40 gallons of raw sap. They don't know about the sophisticated vacuum systems that have revolutionized sap collection, or the reverse osmosis technology that has transformed an age-old craft into a precision science. What happens inside these modern facilities challenges everything you thought you knew about this breakfast staple. The factories themselves are architectural marvels, designed with the singular purpose of capturing the fleeting magic of maple season, which lasts only 4 to 6 weeks each year. During this brief window, these facilities operate around the clock, processing thousands of gallons per day in a race against time and temperature. The chemistry occurring inside maple trees during late winter is nothing short of miraculous. As temperatures fluctuate above and below freezing, pressure changes within the tree create a pumping action that forces sap upward from the roots. This sap contains only about 2% sugar, along with trace minerals, amino acids, and organic compounds that give maple syrup its distinctive flavor profile. But here's what most people don't realize. Not all maple trees produce equal sap. Sugar maples are the gold standard, but red maples, black maples, and even birch trees can be tapped. The age of the tree matters tremendously. A maple must be at least 40 years old and 10 inches in diameter before it's ready for tapping. Some of the trees feeding modern factories have been producing sap for over a century, silent witnesses to the evolution of the industry itself. Modern maple syrup factories have revolutionized the collection process through technology that seems almost futuristic. Gone are the days of trudging through snow-covered forests with buckets. Today's operations use extensive networks of plastic tubing that connect thousands of trees directly to the processing facility. These aren't simple gravity-fed systems. They incorporate vacuum pumps that create negative pressure throughout the entire network, increasing sap yield by up to 50% compared to traditional methods. The vacuum system mimics the natural pressure differentials that occur during freeze-thaw cycles, essentially tricking the trees into producing more sap. Sensors throughout the tubing network monitor flow rates, detect blockages, and even measure sugar content in real time. Some advanced systems use UV light sensors to distinguish sap from rainwater or melted snow, ensuring only pure tree sap enters the production line. The sap arrives at the factory as a clear, slightly sweet liquid that looks remarkably similar to water. This is where the real transformation begins. Before any heat is applied, the sap passes through reverse osmosis machines, industrial-scale filtration systems that remove a significant portion of the water without using energy-intensive boiling. These machines use semi-permeable membranes and high pressure to separate water molecules from sugar molecules, concentrating the sap from 2% sugar content to anywhere between 8 and 20%. This single innovation has revolutionized the industry, reducing fuel consumption by up to 75% and dramatically increasing production capacity. The concentrated sap then moves to the evaporator room, the beating heart of any maple syrup factory. The evaporator itself is an engineering masterpiece, a massive stainless steel apparatus that can span 20 feet or more. It consists of multiple interconnected pans arranged in a precise configuration designed to maximize heat transfer and evaporation efficiency. The sap enters at one end and follows a serpentine path through increasingly hot zones, with water vapor continuously rising from the boiling liquid. The temperature must be maintained with extraordinary precision. Maple syrup reaches its perfect density at exactly 219 degrees Fahrenheit at sea level, 7 degrees above the boiling point of water. This temperature produces a syrup with 66% sugar content, the legal minimum for pure maple syrup. Too cool, and you get a thin, watery product that will ferment. Too hot, and you create sugar crystals or burnt flavors. Modern evaporators use computerized temperature controls and automated draw-off systems that monitor density using hydrometers or refractometers, removing finished syrup at exactly the right moment. The foam that forms during boiling presents another fascinating challenge. As proteins and minerals in the sap concentrate, they create a thick foam that can overflow the evaporator if left unchecked. Factories use food-grade defoaming agents, typically a single drop of vegetable oil or butter, to control this foam. Some facilities employ automated defoamer dispensers that add precise amounts at timed intervals. The steam rising from the evaporators is so intense that it can produce its own weather system inside the building. Specialized ventilation systems with massive fans and cupolas channel this steam outside, preventing condensation from dripping back into the syrup and maintaining comfortable working conditions. On a busy production day, the humidity and sweet aroma surrounding a maple syrup factory can be detected from a quarter-mile away. Quality control in maple syrup production is obsessive and uncompromising. After the syrup reaches proper density, it's immediately filtered to remove a substance called sugar sand or niter, mineral deposits that precipitate out during boiling. This filtering happens while the syrup is still hot, typically between 180 and 190 degrees Fahrenheit, using specialized filter presses or all-on filters. The filtered syrup then undergoes rigorous testing. Technicians measure light transmittance to determine grade, with darker syrups having more robust flavors and lighter syrups being more delicate. The grading system has evolved significantly. What was once called grade or light amber is now golden color with delicate taste. Dark, robust syrup, once considered inferior, is now prized by chefs for its intense flavor. Every batch is tested for sugar content, clarity, and flavor profile. Some facilities use gas chromatography to analyze the complex mixture of compounds that create maple syrup's distinctive taste, ensuring consistency across thousands of gallons. The bottling operation itself is a carefully choreographed dance of temperature, timing, and sterility. Maple syrup must be bottled hot, typically at 180 degrees Fahrenheit or higher, to ensure proper sterilization and prevent mold growth. The bottles themselves are preheated to prevent thermal shock that could cause cracking. Automated filling lines use volumetric or gravimetric systems to dispense precise amounts, with accuracy measured to within a few milliliters. The moment the hot syrup enters the bottle, the container is immediately capped, creating a vacuum seal as the syrup cools. This seal is critical for shelf stability. Modern facilities can bottle hundreds of gallons per hour, with bottles moving along conveyor systems through filling stations, capping machines, cooling tunnels, and labeling equipment. Some operations use induction sealers that create an additional tamper-evident seal on the bottle cap. Quality control continues even here, with random bottles pulled for testing and every batch tracked with lot numbers that allow traceability back to the specific trees and production date. The logistics of maple syrup production present unique challenges that most food manufacturers never face. The entire year's production must happen in a 4 to 6 week window when conditions are perfect. Factories must be ready to operate 24 hours a day during peak season, then sit idle for the remaining 10 months. This requires sophisticated storage systems. Large facilities maintain temperature-controlled warehouses where finished syrup is stored in food-grade drums, sometimes for months, before bottling. The syrup must be kept above freezing but below temperatures that encourage crystallization. Some facilities store concentrated sap in refrigerated tanks, allowing them to extend the production season by processing it after the sap run ends. The equipment itself requires meticulous maintenance during the off-season. Evaporators must be thoroughly cleaned and inspected. Tubing systems in the forest are checked for damage from wildlife, weather, and falling branches. Reverse osmosis membranes are flushed and preserved. The preparation for next season begins the moment the current season ends. Environmental sustainability has become a crucial consideration in modern maple syrup production. The industry has made remarkable strides in reducing its carbon footprint. Many facilities have switched from oil-fired evaporators to wood-fired systems that burn sustainably harvested timber, creating a carbon-neutral process. Some cutting-edge operations use steam recapture systems that recover heat from evaporator exhaust, using it to preheat incoming sap or warm buildings. Solar panels are increasingly common, helping offset the enormous electrical demands of vacuum pumps and refrigeration systems. Water conservation is another priority. The water removed during reverse osmosis isn't wasted. It's often returned to the forest ecosystem or used for cleaning equipment. The tapping process itself, when done correctly, doesn't harm the trees. A properly drilled tap hole will heal completely within a few years, and trees can be tapped annually for decades without adverse effects. Think about that bottle of maple syrup in your pantry differently now. Behind its simple label lies a convergence of forestry, chemistry, engineering, and timing that borders on miraculous. But the story doesn't end with maple syrup. There's another beloved spread that undergoes an equally fascinating transformation in factories around the world. A process that turns simple legumes into a creamy, protein-packed staple found in millions of homes. If you thought maple syrup production was intricate, wait until you discover what really happens inside a modern peanut butter factory, where roasting temperatures, grinding pressures, and stabilization chemistry create the perfect texture and flavor. That video just appeared on your screen, and trust me, you won't look at your next PB&J sandwich the same way again. Make sure you're subscribed so you never miss these deep dives into the hidden world of food manufacturing. And here's a question for you. Before watching this video, did you have any idea that maple syrup production required reverse osmosis technology? Drop your answer in the comments below. I read every single one, and your insights help shape future episodes. The world of industrial food production is full of surprises, and we are just getting started uncovering them together.